All right, welcome back. So today we're going to talk about how we can actually implement the code in our slimes to make them behave like slime, so that if we don't make a match near them, like here, ta-da, we make a new one. Whereas if we do make a match near the slimes, we don't get a new one. So let's dive right in and get started. So where we left off, we duplicated the functionality of these concrete pieces into these slime pieces. So right now, if I make a match near one, everything falls down. Now the idea behind the chocolate pieces in Candy Crush, which I'm calling slime pieces, is that if you take a turn where you don't make a match near one, like here, then you would have another one of these pieces take over what was previously a normal piece. So it kind of shifts your priorities. It makes you prioritize getting rid of these before anything else because they're actively changing the board. Now, like I said, we put these in last time, and I honestly thought about skipping that video entirely and just having you guys do it as an exercise on your own, but might as well do it together. And now we're going to do the actual fun stuff, which is the logic behind how these work. So let's dive right in. So if we take a look at our grid script here, the very first thing that we want to do is we want to create a variable that's going to keep whether or not we've already damaged the slime. So in my obstacle stuff here, I'm going to do variable damaged slime, and by default I'm going to set that to false. Now I'm going to need a couple of helper methods here. Now if I go to my after refill method, this is where I'm going to want to put all my stuff. The first helper method I'm going to create, I'm going to call find normal neighbor. So this is going to look to see if any given piece or any given position has a normal tile either left, right, up, or down from it. And so we're going to call this function find normal neighbor, and this is going to take a column and a row as an argument because we need to know where we're looking for a normal neighbor. So what I want to do here is I want to say if is in grid column plus 1 row. So if column plus 1 row is in the grid, so we're going to say this is checking right first. Check right first. And then also we want to check to make sure that all pieces isn't null in that spot. So if all pieces column plus 1 row is not equal to null, then we're going to return vector2 column plus 1 row. Now this creates a bit of a priority system here where it's going to return right before it returns left. So if a slime piece has, say, 3 normal neighbors by it, say it has one up, right, and left, it's going to return right every single time. So if you wanted to, we could make this a little more random by adding a little randomness to this, like a random variable, and then based on what that random variable is, we're either checking right, left, up, or down. I don't know. I'm totally fine with it being this set. So now I'm going to grab this bit of code, copy it, and I'm going to paste it a few more times. So 1, 2, 3. So checking right first. Next, we're going to check left, and so this is going to be column minus 1 here, column minus 1, column minus 1, column minus 1, and then let's check up, and then this is going to be column row plus 1, column row plus 1, column row plus 1, and column row plus 1. And then the last thing we're going to do is check down. Check down. So then this is going to be column row minus 1. column row minus 1, column row minus 1, and then column row minus 1. All right, cool. So there we go. This is our little method here that's going to find a normal neighbor and return the XY value for that normal neighbor to any piece that we pass in, or any position really, not necessarily a piece, but a position that we pass in. Now the next thing we're going to do is we're going to create a new function that's going to generate that slime. So we're going to say function generate slime, and this doesn't take any arguments in it. So what we want to do first is make sure there are slime pieces on the board. Good Lord. Sorry about that. I have kittens. Anyway, okay, make sure there are slime pieces on the board. So we're going to say if slime spaces dot size greater than 0. So if there are slimes on the board, then get rid of this pass statement here, and we'll add one right there. What we want to do is we're going to create a variable that is whether or not we've already created a slime. So we'll call this var slime made is false. And then while that stays false, we're going to put in a while loop. And you want to be kind of careful with while loops because you do have the possibility of creating an infinite loop. So I'm going to create just another little variable here just to be a tracker to make sure that this loop doesn't become infinite. It's not required, but in some cases it can be good practice. So I'm going to say var, we'll call this tracker equals 0. Now we're going to say while not slime made and tracker less than 100. So what we're going to do is we're going to loop through a certain set of things again and again and again until we get the result that we want. So the first thing that we're going to do here is we're going to check a random slime. So check a random slime. So to do that, we're going to need a random number. So I'm going to say var random num equals floor rand range 0 to slimes, nope, not slime made, slime spaces dot size. And somebody had mentioned that there's an easier way to do this random number. For some reason, this is just the workflow that I have for finding a random number. I like to use rand range because then I can specify the range. Even if I usually start at 0, I don't always start at 0. So I like to have a consistent workflow though. So if I want a random number, whether it's between like say like 1 and 5 or between 0 and 5, I want to have the same way to do it every time. And I know I don't have to do it this way if I'm just looking for an integer between these two values, but I like using floor because then rand range is a bit more intuitive to use. So there are other ways that you can get random numbers in Godot. This is just the way that I like. Anyway, so we're going to check a random slime. We're going to say if slime spaces, and we're going to pass in the value of random num. Actually, no, not what I meant to do. So if find normal neighbor. Actually, hold on for 1 second. Okay, sorry about that. I had to consult my notes. So what I want to do really quickly here is I want to store two new variables. I want to say var current x equals slime spaces random number dot x. So we're getting the x value of that slime space. And we'll say var cur y is slime spaces random number dot y. So we're just grabbing an x and a y value. And then from here, we want to pass those in as the column and the row to see if this slime that we're looking at has a normal neighbor. If it doesn't, we're going to just continue the iteration of the loop. If it does, then we're going to turn that normal neighbor into a slime and exit the loop. So let's say if find normal, actually let's do this one more variable here. So we'll just call this variable neighbor equals find normal neighbor, and we're going to pass in cur x, cur y, and we're going to say if neighbor is not equal to null, meaning if the neighbor does exist. So if we go, the one thing I need to do here then in find normal neighbor, I hate that red highlighting, is if none of these return true, left, right, up, or down, then we're going to return null, so that we have a return in all cases. Okay, cool. And then up here, if neighbor is not equal to null, then we're going to turn that neighbor into a slime. And when we turn it into a slime, we're then going to also set slime made to be true. So slime made equals true. Okay, so to turn that neighbor into a slime, let's go through this piece by piece. So first thing that we need to do to turn it into a slime is to remove that piece. So we're going to say all pieces cur x, cur y, dot q free. So we're going to remove it from the board, and then we're going to say set it to null. So all pieces cur x, cur y, good lord, is equal to null. And then we have to add this new thing to our array. So we're going to say, so add this new spot to the array of slimes. So slime spaces dot add, and we want to add to it vector2 cur x, cur y. Okay. And then the last thing we want to do is we want to send out a signal to the slime holder to make a new slime, and that we want it to make it at that position. So send a signal to the slime holder to make a new slime. So emit signal make slime, and we want to make it at, we've been sending these out, yeah, we've been sending them out as vector2s. So vector2 cur x, cur y. And then slime made is true, and then whether we make a slime or not, we want to add the tracker. So tracker plus equals 1. Okay, cool. So let's just walk ourselves through this again. So if slime spaces dot size is greater than 0, meaning are there slimes on the board, we're going to say that we haven't made a slime yet. We're going to make a little tracker. While we haven't made a slime and our tracker is less than 100, we're going to check a random slime. So we're going to make a random number. We're going to set a current x and current y value to be equal to that random slime's x and y. We're going to create a neighbor variable, which is find normal neighbor. If that neighbor exists, meaning it's not null, then we're going to turn it into a slime. Otherwise, we're going to increase the tracker and just continue. All right, so now, after refill, we're going to generate a slime. And if we don't need to generate a slime, actually, we're going to say if not Did I call it slime damaged? Good Lord, I can never remember my variable names 5 seconds after I make them. Damaged slime. Good Lord. If not damaged slime, then we're going to generate slime. And then we're going to always reset damaged slime to be false so that we're resetting it every turn. And then if we do damage a slime, meaning if in our check slime method, so, okay, this is the one thing we're gonna have to change. 1 second, I'll be right back. Actually, no, I don't know what I was thinking. I don't need to change anything. So for where we damage our slime is down here, this on slime holder remove slime. So when we remove them, if we go through all of this stuff, I'm just gonna add right at the very beginning, I'm gonna say damaged slime equals true. So there we go. Let's save this and let's see how much I broke. So save all scenes, let's hit play. It came up, so that's a good sign. Let's make a match nowhere near the slime. Okay, cool. So I broke something having to do with how the slimes work. Let's find out. Is in grid, expected 1 argument. Oh, so I need to make these vectors. So vector 2, column plus 1 row. And then this should be vector 2, column minus 1 row. So at least it got this far. So I couldn't have done too much bad. And then vector 2, column row plus 1. And then vector 2, column row minus 1. All right, so save all our scenes and let's try this again. And all right, cool. So let's make a match nowhere near the slimes. Haha, it's still broken. What did I do? Non-existent function queue_free in base null. All pieces cur x cur y dot queue_free. Why is it returning? Because the neighbor is fine, normal neighbor. If it's not null, then we're going to return that. Otherwise, we're returning null. And if it returns null, then why did it go in here? Because it should be in here if neighbor isn't null. All pieces cur x, cur y. Huh. Let's add a little debug here. And let's say, let's just print neighbor. Just right there. So let's go out of distraction free mode. Let's hit replay. And here. So let's look at our output. 1, 4. So neighbor is 1, 4. And then on my thingy thing, 0, 1, 2, 3, 4. So it found this one right away. But then x cur y not queue_free. Huh. Okay, I'll be right back. Okay, I don't know what I'm thinking. I'm an idiot sometimes. So here in my generate slime, I'm creating cur x, cur y, which is where the slime spaces are. So of course all pieces is going to be null there. What I want to do instead is I want to do neighbor.x and neighbor.y, because that's where the neighbor is. Good Lord. And then this should be neighbor.x, neighbor.y. Good Lord. I don't know. Some of you guys were probably watching and knew exactly what the issue was before I did. I'm a little slow on the uptake sometimes. Neighbor.x, neighbor.y. And I think that should be slime spaces.append instead of add, because it's not a list, it's an array. So I'm going to change that neighbor.x in just a second. Neighbor.y. So this should be append, I'm pretty sure. All right, cool. So I'm going to save all of my scenes, and let's retry this. See if it's going to work this time. All right, cool. Here we go. Made a new slime. Now let's destroy something near a slime. No new slime that time. Not near slime. New slime. Let's try and do near slime again here. I might need to make a few here. All right, cool. Like I said, it's a little predictable, but I think it's okay. And with a little bit of alterations on your part, you can get it to work pretty much exactly how you want it to. Let's do, oh wow. I'm really bad at match 3 games. I don't know why I'm making a match 3 tutorial when I'm not very good at them. There we go. All right, cool. There we go. So, if you have any questions, feel free to ask them in the comments down below. You can follow me on Twitter, where you can find out when I post new videos the second it happens. You can join my Discord, where I've been chatting pretty much every day. And yeah, I hope everybody out there is having themselves a wonderful day.